Hello guys. Today we are going to discuss about BCS theory. So what is my BCS theory? Bardeen-Cooper-Schrieffer. Okay. So they are the scientists who deliver the what BCS theory. Okay. So what happens in the superconducting state? Okay. Right. So we know about superconductors, right? So what is my superconductor?
Which contain low resistance and at low resistance it becomes a zero.
Okay. So these are only connecting materials. While decreasing the temperature, particular temperature, it exhibits zero electrical resistivity, right? Okay, and then particular temperature is called as critical temperature. Okay, at critical temperature point, what happens in the superconducting state? So why it exhibits zero electrical resistivity? So this was detailedly explained in the BCS theory. So Bardeen-Cooper and Schrieffer, so they have to discover so what happens in the superconducting state. So what's the electrons movement in superconducting state? So they have explained so electrons behaviors in the superconducting state. So this will be explained by Harsik in previous video, lecture video. Okay.
Good morning everyone. Today we are going to see about the BCS theory. BCS theory, in the sense, B stands for Bardeen, C Cooper and S Schrieffer. In the year of 1967, these three scientists were discovered the BCS theory, and it is one of the most successful theory that is going to explain about the superconductivity. What is superconductivity? It is a quantum phenomenon which the material is going to be exhibit zero resistance. Okay, the main aim is to see here at the low temperature how resistance is going to become zero. Let me see here. So, before going to the topic, we are going to see the Coulombian interaction. What is Coulombian interaction? Two positive charges are there. This is going to repel each other. Positive repel each other, negative repel each other, and one positive and one negative going to attract each other. That is the Coulombian interaction. This concept we are going to use here. So, here two terms are there. One is the electron phonon electron interaction. Another one is the Cooper path. Let me see what I want. So to understand these two terms, I took the lattice structure of superconductor. This is the lattice structure of superconductor. In this, I am assuming one electron inside in the motion term. And here current is opposite. Okay, now we know that Coulombian interaction, positive and negative is going to attract each other, right? So here electron exhibit what? Negative charge, and surrounding has a positive charge. So this electron negative charge is going to absorb the positive charges. That is, this negative charge is going to attract this positive charge, and the structure is going to become like this. Electron. See the difference between two structures. Here the electron is attracted with four positive charges, right? So what happened here? This form phonon. See here, highly positive charges are there. So high positive charge density is increasing here. So here what is going to happen? The one positive charge are changing the places, right? So what dissociation of lattice is going to be happen? What is dissociation of lattice? That is known as phonon. Phonon is known as dissociation of lattice. Now, first electron phonon and phonon second electron. See here, we know that current is continuously flowing. So let me take this is the first electron. And here will be the second electron. Second electron is moving towards the first electron. In this way. So, I took this diagram with this first electron, second electron. Second electron is moving towards the first electron. So, the here big bond is formed. So, whatever the length is there between these two electrons is known as coherence length. And the one of the pair is developed here between these two electrons. That is known as Cooper pair. Okay. Now, you see, first electron is interacted with the phonon. So, first electron phonon interaction. and this phonon is interacted with second electron. So phonon, second electron interaction. So first electron, phonon, and phonon with second electron. So one electron, since electron, and this phonon, and the second electron. So this is electron phonon electron interaction. As like this. Now this is the two pair. A pair is developed between these two electrons. That is a two-pair pair. Second one. And we can able to redraw this structure like this also. This is the first electron and second electron as that way. The first electron. Now, as we know that in the superconductor, whatever the electron is there, it will never lose the energy outside. So, because first electron is observed in the hospital, right? So it will lose some energy. So whatever lose energy is there, it will be absorbed by the second electron. So there will be never losing energy outside the superconductor. So in the low temperature itself, resistance is becoming zero inside the superconductor. Now, if I am giving the high temperature, this is what will happen. According to the chemistry, we know that two bonds are there. If we given the high temperature in the cells, the bond is going to break down. So, this bond is breaking, right? Like this, the bond is breaking. Then, if the bond is broken in the cells, the first electron is losing some energy. First electron is losing some energy. It won't be able to accept by the second electron. So the energy will go away from the second electron. So here, in the high temperature, resistance is not equal to 0. Because the condition is in superconductor is temperature less in the cell, resistance equal to 0. Temperature high in the cell, resistance is not equal to 0. This is the process here. Now that's it.